Let's talk about design principles for the CAD modelling phase of your print. We've intentionally left this to last as you need to know the rest of the printing process to be able to actually design for it. Now this is something that's hard to teach just by telling you, but we're going to try our best by giving you some best practices to keep in mind just through some examples. So every time that you're modelling a part to be printed, you first need to figure out which way is it going to sit on the bed. And from that part, every feature that you add to build it up, you need to be thinking, how is this going to affect the printing process? And how is the printing process going to affect this feature? So let's get into some examples. If this was a hook I was making, I would be designing it to sit nice and flat on the bed like so, as this is going to be the strongest orientation to print it in. But let's say we wanted to add some extrusions on the side like so. Now, one on the top is fine, but the bottom one here means I now need to add a whole bunch of supports just to get this part printed. I could rotate it and print it without supports, but for strength reasons, we're going to need it to be orientated this way. So I would probably investigate finding another way to add them, maybe by printing it as a separate piece and then gluing it on later. Now let's say I was printing another version of it with these two hooks here that are perpendicular to each other. Now the one laying down on the bed is going to be fine, but this one here will be much weaker because of the orientation it'll be printed in. So if the project allowed, I would see if I can redesign it so the other hook sits nice and flat like that. But we aren't always that lucky, so in this case, I would probably split the part into two pieces, print them flat, and then join them together later. I think you see a pattern emerging, so it's probably a good time to talk about splitting a part. Now we could get our part, import it into Prusa Slicer and make the split there, but as you will see, doing this in CAD is going to be a lot better. This is a mounting bracket, and this round bit here will act as a joint for an arm to rotate around. Now we need the flat surface of the mounting plate to sit on the bed like so, but the joint here needs to be a perfectly round surface, and unfortunately the variable layer height isn't going to cut it here. It needs to be a bit smoother than that. So in this case, I would opt to split it into two parts like so, print them flat, and then re-glue them later. And because we did this split in CAD, we made it so this one sits nice and securely into the other one, and we won't have to worry about this part breaking. This phone tripod mount we saw before was printed without supports, but as you can see, there's no way to orientate it on the bed without getting overhangs that would need to be printed with supports. This is because it was printed in two pieces, and because it was split in CAD, I was able to join them along this weird T-shape here, which makes it really strong and gives me a lot more surface area to glue the two parts along. You're also going to need to split your part if it's too big for the print bed like this rocket here. Now it is very tempting to just split the STL and slicer, but these were split in the CAD phase, and as a result, these little joining pieces here were modelled into it. If it didn't have these joining pieces like this one, they would be a nightmare to align and glue properly. But with them, it's a piece of cake. And on top of that, it's going to make our part stronger as well. Now we want to use supports as little as possible, so when we're designing the part, we should be taking every opportunity we can to minimize overhangs and bridges. Let's say this is our part here. Now these 90-degree overhangs will definitely need supports, but we can do something simple as just adding a chamfer to them. And now they're only 45-degree overhangs, which can print very happily without supports. This is another piece we're making, and as you can see, we have this 30mm wide bridge here, which is going to need supports. If you're allowed to, you can just add a 5mm chamfer to each side, and now it's only 20mm in length and can be printed without supports. Another example, let's say we're printing this block here, but for visually appealing reasons, we want to get rid of these sharp edges on the bottom surface. You might be tempted to round off this edge, but this actually makes an overhang that's going to need supports. But if we use a chamfer instead, we're not going to need supports at all. Just a quick side note here, chamfers will print and look a lot better than rounds on your parts. Now for something a bit different, but it's really cool. 3D printers don't care about complex or organic geometries. What do I mean by that? This is a little miniature that someone made. Now, I wish I could model something like this, but I can't because I can only use CAD software like Onshape or Creo. But this was made in Blender. Now, Blender allows you to build your part by shaping and molding it like virtual clay. And so traditionally, this part would have been a nightmare to manufacture. But with a printer, it doesn't really care about these extremely complex and organic geometries. This means that you can just throw a texture onto the surface of your print if you wanted to, and the printer will probably not notice the difference. Stefan from CNC Kitchen has an amazing video on this where he adds textures to 3D prints to increase their strength
and stiffness.
So if you're printing something that will be handled, feel free to knurl that surface. It's not going to take any longer or be any difficult to print. Here's a fun one. You can embed text just a millimeter into your prints if you wanted to. The printer really doesn't care. So if we could put all these into a short list, first figure out which way the part will be printed and then see how every feature you add will be affected by the printing process. Design your parts so they can be orientated for strength. When needed, split your parts for improved printability and optimize for them to be rejoined later. See if you can avoid overhangs greater than 45 degrees and bridges larger than 20 millimeters. Chamfers are your friend, rounds a little bit less so. And 3D printers don't struggle to make complex geometry, so use them when you can. Now don't worry about memorizing all these at once. This video was just designed to get your brain thinking about designing for printing. And like I said before, this is a skill that you're just going to learn through lots of experience. So I think that about wraps everything up. Hopefully these videos have given you enough knowledge for you to start your printing journey, but you are going to learn a lot more than what we covered just through your own personal experience. Speaking of experience, good luck on your capstone project and best of luck on your printing journey.